right, good morning. Welcome to Monday, April 27th. We're going to go ahead and move along today to writing equations. What I want you to do is copy the notes as you watch the video. You can pause it, go back, copy as you need. You will need to watch the entire video because you will get graded on that. If you do not watch the video, you will get a 0 for the video part. Anyway, today we're going to talk about writing equations. And after we get done with writing equations, we're going to do types of equations or types of reactions and balancing equations and on from there. So if you remember whenever we did ionic and covalent bonding that I told you we would be using that throughout the rest of the semester, well, we're still using it. So you need to make sure that you have your ion list and your periodic table. If you don't have it, remember it is located in here back towards the beginning of the e-learning. So anyway, let's get started. So with writing equations, you have chemical reactions, which are a process by which one or more substances are changed into one or more different substances. So you have one thing, you react it, make something different. What we're going to talk about today is chemical equations. And this is the process by which one or more substances are changed into one or more different substances. So it shows, go ahead and bring this all the way down, the substances that are involved, the relative amount of those substances. So you have your reactants, which is what you start with. Your products is what's formed. You'll have an arrow between the reactants and products, which means yields, produces, or forms. So if it's written in a sentence form, you'll know yields, produced, to form will be represented by an arrow. And then you'll have letters in parentheses, which indicate its physical state. So S is solid, G is gas, L is liquid. That is not an I, it's an L. And then AQ is aqueous. And then you also have coefficients, which indicate the number of moles of each substance. And remember, coefficients go in front of the element or compound, and it tells you how much of it is. So when we get to balancing equations, coefficients will come into play. All right, so basically reactants yield your products. All right, you have steps to writing chemical equations. First, you identify the reactants. Then you identify the products. You're going to write the formulas for the reactants and then write the formulas for the products. Remember, reactants are on the left, products are on the right, and you're going to place an arrow between them. So we're going to do an example. And on this one, you have sodium combines with chlorine to reduce sodium chloride. Okay, if you notice with this one, I did not put any states of matter in here, but we should be able to figure it out by what's written. So sodium, you know, is a metal. All metals are solid except for mercury. So sodium symbol is Na. We know it's a solid, so we put an S. It combines with, that means you're adding it, chlorine, which is Cl. And if you remember diatomic elements, you have 7 of them. It's hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So chlorine by itself is a diatomic element, so it's Cl2. Chlorine is a gas. And then to produce is where your arrow comes in. And sodium chloride, just remember sodium's +1, chloride is -1. So if I wanted to write it over here, they have the same numbers, so those numbers cancel out. So it's just NaCl. And sodium chloride is table salt, so you know that it's a solid. All right, this one is more of a word problem than the first one. So this one, when solid copper, so copper is just Cu, and this tells me it's solid, so S, reacts with aqueous silver nitrate. All right, silver nitrate. Silver is Ag plus 1, nitrate's NO3 negative 1. Again, they have the same numbers, 1 and 1, so they cancel out. So it reacts with, so that's plus AgNO3. It tells you it's aqueous, so you put AQ. The products are, so once this reacts with it, when it says the products are, then you put your arrow. Then you have copper to nitrate. So we're going to put up here. So copper Cu, the Roman numeral 2 means it's plus 2. And then nitrate's NO3, negative 1. All right, so this 2 is going to switch. So the 1 goes with the Cu, the 2 goes with the NO3. So you have Cu, nothing goes behind it. Then you have NO3. You're going to have a 2 behind it, so remember parentheses. And it says it's aqueous, so we'll put AQ. And it says and silver metal. So I'm going to squeeze that in here. So silver's Ag, metal means it's solid. And yes, that's an S. Okay, so that's pretty much all that is. So that's if I give it to you written in word form, and you have to give it in the symbol form. So I'm going to give you two that are different. So this time, I'm going to give it to you in the symbol form, and you have to tell me in the word form. So Na2O. Na is sodium, O is oxide. So it's just sodium oxide. And we're not going to worry about the solid liquid gas on this one because this and this can be in two different forms. This can usually be in a liquid. All right, reacts with water. You do not have to put dihydrogen monoxide. Water works fine. To form. And then Na is sodium. OH is hydroxide. Don't tell me it's sodium oxygen hydride. It's OH is hydroxide. Use your ion list. Remember, if you have a metal, it's an ion. All right, and then the last example, if you'll notice, these two are nonmetals. So this is your covalent bonding, which means you use your prefixes. So C is carbon. There's nothing behind it, so it's just carbon. S2 is disulfide. I'm just writing out what each one is right this minute. O2, remember, is diatomic, is oxygen. Don't put oxide. CO2, carbon dioxide. And then SO2, I'm going to put down here because I ran out of room, is sulfur dioxide. Okay. So the reason I didn't write it out in sentence form yet is because we needed to make sure what we had. So this right here tells me that this is a liquid. G means it's a gas. Again, a gas and a gas. So everything's a liquid except for, only one thing's a liquid. The rest of it's gas. So on this one, you could write just like the other sentence on the other one. You could put when liquid, carbon disulfide reacts with oxygen gas. And usually you should know oxygen's a gas anyway. The products are carbon dioxide gas, and sulfur dioxide gas. And really, this can be written in different forms. You could say liquid carbon disulfide reacts with oxygen gas to form carbon dioxide gas and sulfur dioxide gas. I mean, you can rewrite this anyway, as long as you're showing that these two things are reacting and it's producing these two things. So anyway, that's how you write chemical equations. I'm going to give you some examples in a Google form. You're going to need to complete those and turn them in. If you have questions, send me an email, send me a message through Remind. Anyway, hope you have a great day, and I will talk to y'all again soon.